Quotient rule part 2. Alright, so we can use the quotient rule because this is a quadratic over another quadratic. Or we can try another simplification trick first. I've got easy factorable quadratic here and quadratic here. If you look at this, this is something squared. If I were to square this after I take the quotient rule, I'll have x to the 4th somewhere in there. So that tells me you can try to simplify now and make life easier on yourself, or simplify later and there's a chance you make an error. So let's just see if I can factor this numerator first. Alright, so the denominator factor is x plus 1, x minus 1. The numerator factor is x squared plus 3x plus 2. Factors of 2 are 2 and 1. They add up to give us 3. So x plus 1, x plus 2. Okay, now we have this. This is my original function. So when I take the derivative of the top now for the quotient rule, I get just 1 times x minus 1 minus the derivative of the bottom, which is 1 times x plus 2. And you can see where these x's are going to go, x minus x over x minus 1 squared. X minus x goes away and that turns into a minus those x's go away. Negative 1 minus 2, negative 3, x minus 1 squared. They want us to do the same thing down here, but we already did it. And what lesson can be learned is if you simplify before you factor, before you take the derivative, you get the same thing. So it's not rocket science, and we're not going to waste time. I think we just put a big X on that section during class. Okay, so we've got P of X equals this quotient. Here, first problem, we start with P prime of 5. So let's figure out what P prime is first. So it's the derivative of the numerator times the derivative of the denominator minus the derivative of the denominator, all of that over the denominator squared. And we're looking for 5, so P prime of 5 equals F prime of 5, G of 5 minus G prime of 5, F of 5. So this is the slope of F at 5. It's a rate, it's a slope. Here we go. So F of 5, I've got this linear function which is negative 1. G of 5 is in this graph. It is 1, 2, 3, 4, 5, 5. Minus G prime of 5, it's the slope here, which is positive 1. F of 5, it's 5 right here. 1, 2. F of 5, 1, 2, 3. F of 5 will give me, I'm just going to call it 3.5. and then all over g squared, or g of 5 squared, which is 5 squared is 25. That's going to equal negative 5 minus 3.5 over 25. So it's going to be equal to something. Negative 8.5, 8.5 over 25. Alright, so I need to simplify this, because if I look down here, I'm actually going to need an equation with a real number in there. So let me find my graphing calculator. I'll just use the phone calculator then. I go 8.5 divided by 25 equals negative 17 over 50. So we found this equation, y minus equals negative 17 over 50, x minus 5. Plug this into your original to get y. Is that where you can see it? Y equals f of 5 over g of 5. Remember, it's p of 5, which is that function right here. F of 5 is, we already said it, 1, 2, 3, 3.5 still. G of 5 is 5, so I go 3.5. Equals y minus 7. So I get 7 over 10. Y minus 7 over 10 equals negative 17 over 5, x minus 5. R prime of 0, we need to find R prime, so R of x equals sine x over f of x. The derivative of the numerator is cosine x times f of x minus f prime of x cosine x all over f x. I want to know what 0, cosine of 0 is 1. Let me write it out. That's why we do these, so I can slow down. Sometimes we lose time in class answering questions, which is why we started this. Cosine of 0 is 1. F of 0. F of 0 is negative 5. F prime of 0. It does not give me f prime of 0. So I'm going to estimate f prime of 0 from here to here. What is that slope? That slope is 2. Cosine of 0 again. which is incorrect. This should be sine of 0 anyway, so it doesn't matter. This should be sine of 0, which gives me 0 over the whole thing. F prime of 0 again is 5 squared is 25. That's negative 5 equals negative 1/5. Now it wants to know the equation of the tangent line. Now, when x is 0, r of x is also 0, because sine of 0 is 0. So y equals negative 1/5 x. Last page. Tables. G prime of 2.5. Alright, so that's kind of how I did on the last one. 2.5 will be between 3 and 2, so we'll use that slope of g of 3 and 2. So g of 3 minus g of 2 over 3 minus 2 equals g of 3 is negative 3 minus g of 2, negative 1, negative 3 plus 1 is negative 2. There you have it. Here I have a product, and inside the product rule I'm going to have a quotient rule. So I get 4x times f of x times g of x plus 2x squared, and then in here I'm going to have a quotient rule. So I'm going to have f prime of x g of x minus g prime of x f of x, all that over g squared x. And I want to know when x equals 2. So 4 times 2 times f of 2 g of 2. Let's just go 8 f of 2. F of 2 is 2. G of 2, negative 1. That's going to be negative 16. Two times 2 squared is 4 is 8. And then we got this part. F prime of 2, G of 2, G prime of 2, F of 2, G 2 squared. So F prime of 2 is 9. G of 2 is negative 1. G prime of 2 is negative 1. F of 2 is 2 over G squared of 2. So G of 2 once again is negative 1, so that's just going to be 1. So I get 8 times 9 times negative 1 is negative 9 minus negative 2. So it turns into plus 2 over 1. Negative 7 over 1 is negative 7 over 1. And that's going to equal negative 56 minus 16, 6. 10 and 56 is negative 72. Another quotient rule, p prime of x, g of x, f prime of x minus g prime of x, f of x, all over. See, I got that backwards. They switched it on me. So this will be g prime of x, f of x, all over f of x squared. And so they want to know in 4, so g prime of 4, negative 2, f of 4 is 1, minus g prime of 4, or g of 4, 7, f prime of 4, 8, f prime of 4 squared, or f of 4 squared is 1, negative 2 minus 56 is negative 58. Last one. Derivative of the top is 3 times the bottom minus the derivative of the bottom times the top, all over this squared. Plug in 3. G of 3 is negative 3. So down at the bottom, negative 3 squared is 9. Negative 3 is negative 9. Negative 3 times 9. So I get negative 9 plus 27. Negative 9 plus 27 is positive 18 over 9, which is 2. So this is my slope. Minus equals 2x minus 3. Plug this into y. I get 3 times 3, 9. We said that g of 3 is negative 3. So y plus 3. Alright, that's it.